Welcome to this month's webinar on facility considerations for distillation design. And we've got our two experts on the line with us here, Scott Saneholtz and Brett Rygalski. And I'll turn it right over to them to get started.
Well, good. Good morning, everyone. I'm Scott Saneholtz, Senior Manager in the Sales and Marketing Department. Before that, it was with in our Process and Mechanical Department for a dozen years or more. We're going to talk today about the facility considerations in distilleries. A lot of the process pieces are very visible, but designing a facility around the process is equally important. Doing them together will create a more of a seamless, better project for everyone. So our agenda today, we'll start with a quick overview of who Matrix Technology is and Brett and myself's backgrounds. We've got some folks on the line that are probably not as familiar with distilleries as some of the others that are on the line. So we'll talk briefly about a process overview and talk about a couple of specific areas of concern when we talk about risk. Then I'll be passing that over to Brett, and Brett will continue on with more facility issues as far as space planning, classifications, fire protection, etc. We'll close with some Q&A, and we'll see where we go from there. Hopefully, it'll be some good information and some good questions from everyone as well. Quick about Matrix Technologies. We've been around since 1980. We're a 250 plus person company with generating $55 to $60 million in revenue. We do projects all over the world. We concentrate mostly in the United States. And one thing we'll always tout is that 85% of our projects are with repeat customers. So we're building partnerships. We're not looking for the one-offs. And in the last several years, that has meant that we've had quite a bit of success in the distillery and spirits industry. We work across all kinds of different sectors, oil and gas and chemical, wine and spirits, food and beverage, a little bit of pharmaceutical as well. All those different areas and all those codes and regulations and things that we've learned over the years about managing risk are all brought to bear on the projects within whatever industry we're working on. Today, we're talking about distilleries in the wine and spirits. We are a full service engineering firm. We do the nuts and bolts process of facility engineering, of which Brett and I are more familiar with, but we're also a nationwide leader in the industrial automation and MES information systems. And given the right size project, we'll carry on the EPC as we don't self-perform, but we'll carry the paperwork. We have construction managers on staff who help our clients make these projects a reality. And then a little bit about me. I got my chemical engineering degree from Cincinnati back in the 90s. And after maybe the first decade or so of my career in research and development and manufacturing, I've been with Matrix Technologies since 2004. In 2008, I became the manager of the Process Solutions Department, which is our process mechanical and piping groups. And in the past year, I've rotated into senior manager of applied solutions within sales and marketing, where we want to work with our clients to help them bring new ideas to reality. So we're focused on a project definition across multiple industries. And the cute fact that everyone's asked me to include is that I'm seeing the world in alphabetical order. The two big trips that we've taken in the past 6 or 7 years, Alaska and Australia. So I think the next one might be Argentina or maybe Austria. I'm not sure. I'm still on the A's. There's a lot of countries to see. So I'll pass it over to Brett for his introduction.
Yep, thanks, Scott. So my name is Brett Rygalski. My background is I got my degree from University of Toledo in civil engineering. Then I got my MBA about 7 or 8 years ago. My past roles at Matrix, I've been here since 2006, 15 years. Was in our facilities group for 9 of those 15 years. Did structural engineering in the group, a lot of buildings, manufacturing facilities, working with processes as well. In my current role at Matrix as a senior project manager, I've been doing that for 6 years now. I've managed a lot of projects with our multidiscipline engineering and automation, batching, bottling, packaging, and then manage a handful of our EPC or EPCM projects that take it all the way from the design through the construction phase through the checkout and commissioning phase as well. So my fun fact, I'm a triplet. There's 2 others that look something like me, but not as good as me.
Okay, thanks, Brett. As I said at the top, you know, the goal of this webinar is to talk about the risks in the building really around the process. But since we got some folks that aren't as familiar with the process, we'll talk a little bit about that. You know, there's the distillery handles materials in different ways. There's at the front end, there's the grain handling and the grain dust issues, and the back end there's the higher alcohol distillate. But each of these unit operations, you know, has their own unique challenges, both within the process and within the facility. You know, you can see, you know, the need for venting of a tank, but you don't always see the need for fire protection or how to do that properly. So you know, everybody's got different needs. The process areas are more visible, but the process safety pieces and the facility life safety pieces really need to be worked together during the design in order to get your optimal result and the best solution for your project. You know, like I said, quick overview of the process. You know, our spirits are made from the natural grains of corn and rye and malted rye, and they're typically delivered in bulk and stored in bulk, and they need to be ground and milled. And that milling, the grain handling and milling steps, you know, are very noisy, and there's a grain dust explosion concern as well. So those things need to be designed into the spacing and the venting of those rooms. Now we get into cooking or fermenting, where we're actually turning the grains into the sugars and the alcohols of the mash cooking, the fermentation. There's not a lot of risks in there other than kind of like your standard process risks of, you know, don't overpressure a line, don't block in a steam heat exchanger, so you're going to have an issue with that. And you know, during fermentation, there's a lot of carbon dioxide involved. You want to be sure you've got that vented to a safe location outside the building to prevent a reduction in oxygen environment. Of course, then we get to the fun stuff, which is the distillation column. A lot of the larger facilities do this in a continuous distillation procedure. You know, a lot of this is done with specialists in distillation and distillation column design, and we make sure that all the process around the equipment is there, as far as making sure you got culinary steam to provide the heating, that you've got proper cooling where you need it, that proper ventilation where you need it as well. And the overs that come off the top of the distillation column, that's where really your risk comes in, because now you're at, you know, 130 or 140 proof, and that it needs to, those vapors need to be controlled, they need to be condensed, and they need to be sent to proper storage for barreling or trucking off or whatever's being done. Obviously, we're going to eventually barrel all these things off and age them and turn that into the spirits that we imbibe on a regular basis, unfortunately, I suppose. But you know, the flame arresters around the distillate tanks need to be, and the emergency venting for dealing with a fire case, very important around the distillate storage tanks when you've got a 50+% alcohol content within the tanks. So there's several areas involved in unit operations. So you know, those considerations that are, I still say they're more visible because I'm seeing the tank and I'm seeing the tank full of alcohol. They need to work in concert with the design of the facility, the access, the life, the egress and things like that. And you know, that's where Brett's expertise comes in. That's where the process team at Matrix Technologies works with the facilities team to do a smooth, an optimal handoff and make sure that things work together well. So Brett's going to kind of carry the ball from here to talk about the building itself and the spaces around the process.
Cool. All right, thanks, Scott. So spatial planning, it's a very important step in the design of your facility once you get the process defined. Greenfield sites, they're ideal. They allow you to have the flexibility to design the building around the process versus the process around the building with a brownfield, but sometimes that's not always the case. To define your space, it's important to understand your process constraints and your equipment needs, what your anticipated output of your column and your equipment sizing. How do you plan on storing your products? Does a column feed directly to a storage tank? Is it a day tank? Where do your power feeds come into the space, and how close do you want your control panels to the devices? Where your operator station is going to be located at, and what type of access do you need? You know, do your platforms or mezzanines, are they required for your instrumentation or your valving access, or even access to the top of the tanks? And it's also very important now to plan for the future, your future needs or your future growth. It's going to cost you a little bit more on the design side up front, but it's going to save you a lot of money and a lot of headaches down the road as you go to expand your facilities. Once the space is designed, the next important step for you to do is an architectural code review. Depending on your state or your municipality, this could fall back on state code or international building code, as well as the fire codes. It's important you verify with the state you're working in to make sure you have the right version that they require. Another great reference is Discus. It's kind of the Bible for the spirits world. It provides info from the industry and also recommendations for design. It doesn't always match what the building or fire code calls out, so be cautious on that, but ultimately it's a good guide for your design considerations. Your architectural code review is going to address several key items for your building and your spatial planning. One of them is your occupancy classification. Typically in the spirits or distilling world, that's a hazardous or H use. The construction types, what your building is going to be built out of, type 1 construction, 2 or 3. That's fire resistant, non-combustible, or ordinary construction. So that's your steel, your masonry, your concrete. Allowable floor area and building height. Those are based on the classification and construction types that you define in a couple steps before that. And egress paths, those are really important for your facility considerations. These are paths or corridors in your building that provide safe access points for your staff in the case of an event or a fire. So defining those and defining those paths in and out of your equipment or up and down equipment as well is pretty critical. Other items that I'm going to dive into a little bit more detail here are the electrical classifications, fire protection, drainage and containment, and ventilation. So electrical classifications really revolve around the hazardous areas that you define as part of your code review. Typically, we're working with the H groups, as I mentioned in the last slide, which are your hazardous groups. With alcohol handling, we're in the Class 1 Div 1 or Class 1 Div 2 realm, where Class 1 means vapors are present in the areas in large enough quantities to cause an event. And then the Div 1 is they're present under normal operating conditions. And Div 2 is really present in abnormal scenarios. So for example, that would be your grain handling or a tank failure or a system breakdown that it's not anticipated, but it could happen. These ratings do drop the further you get from the source. The image I have here on the screen is taken out of Discus. So it kind of shows the classification bubble around the equipment. So you can see here You've got the Class 1 Div 1 radius around the tank and into lower lying areas, and then your Class 1 Div 2 kind of go around that bubble, and then as well as your exhaust points on the flame arresters or conservation vents. That bubble does grow a little bit. So the further away from the equipment, obviously the better your classifications get, or the less stringent they become. Examples of areas of concern for electrical classifications. This would be your manways or your sample ports, flame arresters and conservation vents. Scott mentioned that earlier, and we just looked at it at the previous slide. This will vent your tank, and also in the event of some sort of fire inside the tank, that's a good avenue for the fireball to exit out of. You've got pumps and flow panels and transfer points. And then you've got your piping connection. You've got your tri-clamp connections, which are usually on your instrumentation or valves close to the equipment. And then you also have flange connections too that that could either be on your tank or that could be on piping spool pieces that run through your facility. Just a few mitigation methods for the electrical classifications for the space. You've got grounding rings, rods, or wells. These could be existing or new. It's important that you make sure that your facility has some sort of ground on site, so that way you could properly discharge any static that might exist. You've got equipment and piping grounding. This is tanks, columns, mezzanines, and even bonding between pipes. The top left picture there kind of shows the bonding of the tanks to the steel that was underneath it. So during your tank design, it's important that you incorporate these tabs or some sort of mechanism to attach that grounding to. We've got static relief devices. It's the clamp-on style kind of shown here below. It mainly occurs in unloading scenarios where you have a clamp that will basically you squeeze it, you put it on the truck, and then it sends a signal to your program, or it can be a manual operation that basically says, yes, I've confirmed that I'm grounded, ready to transfer. Lightning protection is another one. It's often forgotten about. But your distillation equipment or even your structure could be the largest structure on site. So you want to make sure that you're protected during those freak storms that happen. And then your electrical seal-offs. As you break the classification bubbles, you just want to make sure that your electrical connections are properly installed and isolated from one space to the next. Switching on to fire suppression. So fire suppression requirements are often dictated by NFPA, your local fire code, your insurance company, or a combination of all the above. There's several types of fire suppression systems to consider. First one being the water system, pretty traditional style of suppression. This basically is a wet system that's in your facility and requires of a demand of up to 120 minutes of sprinkler water in the event of a fire. It's a cheaper style of installation, but will have an effect on your drainage and containment, which we'll touch on in a little bit. Second type of system that I've seen quite a bit in the spirits world is a foam water mix. So this does take a tank, kind of the lower picture there, that mixes with the fire water and puts out the fire that way. The advantage of this system is demand goes from 120 minutes down to 20 minutes, which drastically reduces the volume or the demand on your system, and also minimizes how much you need to contain. Another system that can be used is a dry system. This would be a clean agent like FM200 or CO2. The advantage of this is it's a minimal duration of suppression required, and it's kind of a quick hitter. I've not seen it used too much in the spirits world. I've seen it mainly around isolation on equipment when you need to put that in an enclosed space. And finally, fire extinguishers. Just make sure that you've got those located in your facility. This can be laid out by your architect, your maintenance team, or even the company that supplies and services them for you. And another note on that too, just make sure that those are checked and serviced yearly. Some other considerations for your facilities on fire protection is your fire pump design. Depending on what system you select, water or foam, you want to make sure your pump has the capability to meet the demand. As I just mentioned, you've got the 120 minutes of supply that you need for a wet system, so that's pretty taxing on a system. So you want to make sure you check that supply pressure that your municipality can supply to you, and if that pressure is not adequate enough, which is oftentimes the case, an elevated water tank may be required to meet those needs. Another thing to consider is your fire alarming and your strobes. It often gets overlooked in the process, but it's important to make sure that you install this to alert your staff in the event of a scenario. Again, work with your architect and your fire suppression engineer to make sure that these are located in the proper locations. Obstructions are another thing to take into consideration too. Tanks, I've seen fireheads dropped below tanks or low spaces that are big enough to occupy somebody, but a space you wouldn't go into, not necessarily a confined space. But depending on what those are, you may have to locate unique sprinkler heads in your facility. And again, be sure that your equipment's serviced and maintained to meet the facility's needs, and keep records of those testing requirements for your own use and for your insurance company's use. And finally, work with your local fire department. Discuss the project with them, let them know what you're planning on doing. Some municipalities don't have the ability to fight the fire with foam, or they don't have supplies or limited knowledge on foam firefighting. So use this as an opportunity to work with them and supply them with a small contingent of foam for their use. It can go a long way with them, with the relationship, as well as the process or the project installation. You know, another thing to throw out there too is if you've got large tanks or vessels during the construction process that are open and easily accessible, offer up a joint training opportunity. We've done this before in the past on another project, and it was a great way to engage the fire department and get them on board for what the project is. This is just this is taken out of Discus, just a quick recommendation for fire suppression. By no means is this a end all be all, but it's a good starting point for some of your fire suppression demands and needs. All right, moving on to drainage and containment. This is an important consideration for the design of your facility as well as the layouts, whether it's new or old. The goal of your containment should be to isolate or prevent your spills from entering any areas that they shouldn't be, whether that's public ways, unclassified sewers, or classified areas. Standard practice of the industry is really 110% the largest volume. So if you've got a tank, you want to take 110% of that volume to contain, or the largest contributor. So work with your maintenance team to identify what sources might be or how you need to plan for them. The sources could include your equipment, that's your columns, your tanks, or your pumps, your piping connections, washdown areas or CIP areas. And then back to fire protection is, you know, we talked about the foam versus water. Depending on which system you select, that's really going to be the driver of your containment footprint and size. So that's usually the governing factor for what you're getting into. These are just a couple of examples of drain systems that can be installed at your facilities. I've taken actually all of these from projects that I've worked on in the past. First one is really curbing. If you've got a large area and you can spread the volume out, you don't necessarily need really tall containment walls. So you can go ahead and get away with small curbing that gets you in and out of spaces. So this was a stairwell that we didn't want anything going down. Second picture, top right, is the spill barrier. What I like about this device, well, let me explain how it works. So there's a sump system inside of there that it will detect the liquid fill up, and it's a spring operated door that comes up. You know, this system is great for containment walls and allows you the flexibility to be able to drive equipment in and out of there without bringing in a large lift to, you know, lift a fork truck or lift a scissor lift into place. So this gives you the ultimate flexibility. They are a little costly, but they definitely save some headaches down the road when you need to get into that space again. And then you've got spot drains and trench drains, pretty typical installations for most facilities. And then other considerations really include the design of your underground sewers. Scott and I actually ran into a project recently with some alcohol handling where, you know, there was a big debate about the materials of construction. It's important to take that into consideration and the compatibility with alcohol. Last thing you want to do is either, you know, construct a new facility or renovate a facility with brand new drains that you have to replace in a couple years because somebody didn't pay attention to the pipe that was run underground. This compatibility also applies to floor toppings. Not all can handle high proof spirits, so just keep that in mind. And also for the drains too is to look at traps. I've kind of gone both ways with this before. You know, traps are good that they prevent the vapors from coming back up into the drains. If you think back to a few slides ago where we showed the kind of the low points where the vapors will collect. The trap will help prevent that kind of escaping that area, but you can also consider free draining this to an isolated location so you're not trapping alcohol either. The other thing to consider too is really how are you transporting this? I've seen lift stations used to transport this waste material. One thing to take into consideration with that is just the redundancy of the pumps. You always want to have a backup. You also have to consider that these are classified spaces, so your rating is going to be Class 1 Div 1. What I've seen in the past, and I like this, is really putting like a stack light or beacon up there to let your operators know that the pump is functioning or if there's a fault on it. So it's a good visual for them without physically checking the float to make sure everything's working. And finally, you just need to keep in mind where your waste goes. Are you sending this directly to the municipality? Are you trying to pre-treat this on site with a skid, or do you have your own wastewater treatment plant? Regardless of your method, it's important to understand your water quality and requirements for the discharge or your effluent. Most spirit companies usually do pre-treat or treat on site before discharging it to the municipality. Last thing you want to do is send high-proof spirits to the city and kill all the bugs in their tanks. So just keep that in mind as you get through your underground drainage needs. And finally, it's almost over. The rule of thumb for ventilation for the space is really 1 cubic foot per minute per square foot of room space. So if you've got a 10,000 square foot room, you want a unit that's capable of 10,000 CFM. Because the alcohol vapors are heavier than air, it's critical that you have a high supply and a low pickup to make sure that you exhaust those vapors in the space. A recirculated system with fresh air makeup can be installed. Just make sure when you choose this, you can have gas, steam, or electric, but you need to be sure that you're not in direct contact with the flame because you may have some vapors in that airstream that you don't want to ignite. But regardless of the type of unit that you select, it's key that you have LEL detection or low explosive limit detection in the system. Should the level exceed 25%, you need to make sure that your HVAC system goes into full exhaust mode and supplies with 100% outside air until you either resolve the problem or the levels are reduced. But even if the levels are reduced, it does behoove you to troubleshoot this system to figure out why you hit that level. Also, putting in isolated exhausts for certain areas. For example, like a filler, you're going to have constant open product there. You may want to put spot exhaust fans in that location to make sure that you're not trapping any vapors anywhere. And it's also important to make sure that you have the system tied to a backup power supply. In the event of a power failure, that's the last thing you want to go is your ventilation system, and now you're just trapping all of that alcohol vapors, which are low, in the space, which could cause an event. So just make sure that you protect yourselves and hook that up, at least minimally exhaust to a backup generator. And then just engaging the insurance company. When is this important or why is it important? My recommendation is you get them involved sooner than later. Most insurance companies, they do hire a risk consultant that's kind of the buffer filter between you and the insurance company. And they should be able to provide you criteria for what they're basing the policy on. I like to get them involved in the design process as well, from the kickoff to a 30, 60, 90 checkpoint, whatever works best for you. But usually they'll knock on your door and ask some questions. But their feedback can really help steer the project in the early phases, versus at the end of the project, which could derail schedules or budgets. So again, if you can address it up front, that's the best time to do it versus on the tail end. They're also willing to work with you and give you guidance on how they've seen things in the past. They may say, well, what you're trying to do there is it's going to raise your premiums, and consider doing it this way. We've seen that at another facility. I also like to get them involved with the design process, but also the tour of the facility, during the construction efforts or even at the commissioning phase. It does go a long way to show that you've incorporated their comments and recommendations, and also, helps keep your premiums at a low if they know that you've listened to them. So I also like to engage the local municipality as well as the fire department, just like the insurance company. Get them involved from a state and local level. This could help with incentives that come to play with your project in the area, and can also be a good PR avenue for your company. You know, again, review at project milestones from kickoff to construction. If they understand the project and the goals, this can help facilitate with your permitting process. You know, my experience is really the distilling world is kind of a foreign language with some municipalities. They don't always understand exactly how your process works or how it operates. So if you get them to understand it early on, it just makes it an easier process down the road. And I mentioned this a while ago, and I'll harp on this because it really benefited us on a recent project, is keep engaging the local fire department or the fire marshal, keep them in tune with the project. This will help with the local code review as well, because you go to state, the state will kick it back to the local, and the local will kick it to the fire department. So if they know what's going on, they know what products you have in there, they know how to fight the fires. It's a great, you know, it's a great tool to keep the permitting process moving forward, and it's a good gesture to the community. You know, you can coordinate your training on site, like I mentioned, you know, training in vessels or tanks, or even offering up the contingent of foam. It just goes a long way. And that's kind of it for me. Really, just some key takeaways here is just really understand your process and your spatial needs. You know, define that up front. And try to build the building around the process. Again, that's not always a possibility. Sometimes we have to deal with the envelope what we have, but defining that early on and knowing what your current plan is and your future plan is going to save you a lot of time and money. Don't forget about your architectural code review or your hazardous classification review. This is really going to dictate your building types and constructions and egress paths, and really define your fire suppression, your drainage and ventilation. So that's really the first step in all of this. The proper fire protection systems, water, foam, or dry. You know, there's really no right or wrong answer. So it's really based on the needs of your facility and, you know, your supply that you have. Again, if the municipality water supply is bad, you'll have to consider an elevated water tank to fight your fires. And then ensure the means and methods for your containment. Identify those source points of where your leaks could be, look at your largest tank volume, and then also go back to your fire protection. That's going to be really the driver for your containment area. And ventilation, you know, make sure you have the proper ventilation. Exhaust is critical, and then detection in your facility. You know, that's the last thing you want to do is pool up, you know, all these vapors in your building, and somebody flip a light switch and things don't end well there. So make sure that you keep that into consideration and in your backup systems for that too, in the event of a power failure. And this is key for me, is just engaging the insurance in the local jurisdictions. Don't be afraid to talk to them. I mean, if you're afraid to talk to them, then you have something to hide, which, you know, you need to be kind of transparent, and it makes the process go so much smoother. It helps on the expense as well as schedule as well as permitting. So don't be afraid to have that conversation, and don't wait for them to engage you. Engage them up front and just let them know what's happening, and your life will be a lot simpler. So that's all I've got for now. Appreciate you guys attending this. I don't know if there's any questions for the group.
Yep, there's a couple that have come in, Brett. So I think they're related at some level. I think you may have touched on the first one, so I'll read this to you, which is, in your experience, when does IFC explicitly require backup power for ventilation systems?
When does it require backup for?
When does it explicitly require backup power for ventilation?
I couldn't tell you this specific section. Really, my experience with it really comes from the insurance company's driver, that they want to see that backup really from a risk liability standpoint. I could definitely do a little bit more research into the IFC to see exactly where that says that, but I don't know off the top of my head.
So then the one that's related to that is, how do you interpret NFPA IFC code as requiring continuous ventilation at all times while processing, or you have any experience with installations that only activated ventilation once the lower explosive limit was detected, say above 10% at full vent?
I mean, I've seen it both ways, you know, depending on how you want to condition your space, you know, with with distillation, you often have a lot of heat in the area, and you're going to be constantly having that battle of trying to cool the area down. So you may, in that situation, you may want to just have the exhaust only, but you are required to have a certain amount of makeup air in the space. So you have to do something with that air at the end of the day. But I've seen it both ways. LEL detection, I've seen it, 25% is kind of the recommendation, but you can go at a lower level for that if you choose to. But I think it all revolves around the areas that you're trying to protect or ventilate. Not sure if that answered the question or not.
And there's another question, again, somewhat related to this topic, which is, can you touch on the topic of ventilation being used to reduce the electrical hazard classification? I guess the question is that possible?
Yes, I have seen it, and we have used that in the past. As long as you meet the requirements of the air changes per hour, I have seen that drive your classifications down. It will shrink your bubbles a little bit. Again, I referenced back to the code on that, and then your insurance company. But you put that into play, even your fire suppression systems too can help dictate or drive down some of the classifications. So but with that ventilation now, you need to have that backup power source to ensure that you can maintain the classification level no matter what happens.
Well, I think I would add too, Brett, that these things all work together. And I think we kind of mentioned that early, is that you mentioned a filler. We didn't really talk about the back end of the process or, post barreling, but, can you isolate the filler and the open bowl of the filler at the bottling line so that you can minimize the ventilation and minimize the classified area, or is the design such that you have to have a larger area, a larger volume of air to move, a larger classified area? So where you put walls, how you isolate operations from one from the other, how you optimize your working space so people can work in there and materials can move the way they move, and yet not oversize the ventilation, because all of a sudden you just have essentially this big warehouse you're trying to ventilate properly, versus the cost of adding those walls versus the cost of multiple air handling units. Those all come into play, along with the insurance company and the local jurisdictions' willingness to accept risk, and the client's willingness to accept risk and probability as we work through all that. So questions aren't simple answers, because there's a lot of players and a lot of options to look at. And that's where I think that's probably one of the goals of this webinar, was to say, look, there's a lot of different options. We've been through this with larger facilities and smaller facilities, and we have some experience that we can bring to the table to help you figure out the best answer for your project.
All right, next question is, how are relief devices selected?
Well, yeah, that goes back to kind of what I started with on the process side. The relief really comes into play around the distillate tanks. The in-breathing and out-breathing needs to be protected with flame arrestors, and needs to be sized for, obviously, filling so they can out-breathe, emptying so it can in-breathe without damaging the tank. But then there's also the situation of the emergency venting, where if there is a fire in the area and contents within the tank start to vaporize and start to increase the pressure, then there needs to be an emergency vent as well to basically pop off and vent that to atmosphere, to control the situation. So really there's kind of a twofold thing. One's kind of simple breathing with flame arrestor, but then there's also the fire case, which takes precedence.
All right, next question is, should you consider hose stations or fire monitors with new construction?
I would say no. The reason for that is you really need to train your facility or your operators to be able to fight the fire. and most companies don't really have a on-site fire brigade that would do that. So really, if you were to put those in there, you need to have people trained to use it, and the fire department's not going to use it because they don't know if it's been maintained and the serviceability of it as well. So I would shy away from doing that because it's probably not going to be used by the fire department, and you're not going to want to train your staff unless you have a very large facility that you need to do that at.
Okay. And the last question, at least right now in the queue, is how do you typically design the venting for the fermenters?
Okay, so fermenter vents, you know, there's not really a need there other than making sure that the outlet pipe is, again, typically through the roof with a hook on it and a screen at the end to keep the birds out. But it really, if the fermenters are really free breathing, the biggest concern is to be sure that that CO2 that gets evolved doesn't pool somewhere within a building where somebody might be. So typically those are just oversized lines that head through the roof.
Okay, well, at this moment, there are no other questions in the queue, so I think we can go ahead and wrap it up.
Yeah. So if you guys want to just learn anything more, or I guess rewatch this or see any of our other contents, we do have a hub, Matrix on Manufacturing. The PDH certificates will be mailed out by the end of this week. And then just upcoming here in July, we do have another webinar hosted by Jerry Francis on the success and challenges of EPC projects. So that too, I assume we'll have another PDH associated with that. But I appreciate everybody attending today.